to be looking at relationships among variables. So let's consider a medical study that finds that short women are more likely to have heart attacks than women of average height, while tall women have the fewest heart attacks. Or maybe we have an insurance group that's reporting that heavier cars involved in fewer fatal accidents per 10,000 vehicles registered than our lighter cars. Well, in these two examples, you might be led to believe that being taller leads you to have fewer heart attacks, or maybe that a heavier car is actually safer. But we actually need to look a little bit further into these relationships between the two variables, because often when we see relationships between two variables, there's often a third lurking variable in the background that is strongly influencing what's happening between the two variables in a study. So in order to examine relationships between two variables, we first want to plot our data and then add our numerical summaries, either the mean and the standard deviation or the 5-number summary. We want to look for overall patterns and deviations from those patterns. And if the overall pattern is regularly, then sometimes there's going to be a way for us to describe it briefly. So we can see here, this is a scatter plot of the percent of nutritionists who say a food item is healthy related to the percent of American voters saying a food is healthy. So basically, we're looking, do Americans agree with nutritionists on which foods are healthy and unhealthy? So we see on the x-axis, these are the results for the nutritionist, and on the y-axis, these are the American voters. And so each food item is one of the dots on this scatter plot. So we can see most of the dots here are there towards the middle where people are agreeing. Most people and most nutritionists agree that soda is not healthy. French fries, chocolate chip cookies, things like that, there's agreement between the two groups. But if you look at something like a granola bar, we can see here that nutritionists are ranking that pretty low. It's only at about 25 or 30% of nutritionists say that a granola bar is healthy, whereas Americans, it's somewhere around 75%. So there's a huge discrepancy that nutritionists think that granola bars are not very healthy, but the perception for Americans is that it is healthy. Same with granola. We also have, as Americans, a much higher perception of granola being healthy. And then on the other side, things like tofu, quinoa, and sushi, nutritionists say that that's a lot healthier than Americans are describing them. So generally, as the percent of nutritionists saying a food item is healthy increases, so does the American voter. So there's an agreement for a lot of these foods, but we've discussed some of the ones that are out of the normal pattern. So this is an example of a scatter plot, which shows the relationship between two quantitative variables. Now on these scatter plots, it's two variables that are measured on the same individual. So you'll have the value of one variable on the horizontal axis and the value of another variable on the vertical axis. So each individual in the data appears as the point in the plot, and it's fixed by the values of both variables for that individual. So if we have this explanatory response type relationship between our two variables, we would always put the explanatory variable on the horizontal or the x-axis. Now, there's not always going to be that explanatory response distinction, and in that case, you can put either variable on the horizontal axis. This is another example. This comes from the World Bank for 2016, and we're looking at the gross domestic product per capita and US dollars compared to the life expectancy. So we would think maybe that the gross domestic product, how wealthy a country is, could influence the life expectancy for those countries. And we see that this pattern here, the ones that are in that solid blue, is there's a lot of really poor countries that have a lot of varying life expectancies. So all of those countries there on that far left have varying life expectancies, but they all have a relatively low GDP. Now, the United States does not actually quite fit the mold of what's going on with most of the other dots in that range of countries that are a little bit wealthier. The US actually is a little low for life expectancy compared to other countries with a similar GDP. And then on the far right, we see Liechtenstein, which has a very, very high gross domestic product per capita, but they also have a high life expectancy. So we might want to know, what does this scatter plot tell us? So this scatter plot helps us see that rich countries don't really live longer than people in poorer countries when we compare to some of these extremely poor nations. So for example, Costa Rica actually has a higher life expectancy than the United States, but they're much poorer. And then there's two countries that are also worth noting. I've already mentioned Liechtenstein, but Equatorial Guinea is also an interesting case. Their life expectancy is very, very low, but they do have a little bit higher of GDP than most of the countries with such a low life expectancy. And so we might ask, what else could be happening in this Equatorial Guinea? And it turns out that it's an oil-producing country, and so there are a few people who are making a lot of money off of the oil, but that income is not being spread out among the entire country, and so it's not increasing any of the life expectancies of the ordinary citizens. And then what's happening here with Liechtenstein is that it's actually a strong financial sector. It's a tax haven for many corporations. And so here you have a very, very large GDP for such a small country. So when we look at these scatter plots, it's important for us to look at the overall pattern and look for any striking deviations. What are the individuals that follow the pattern, and what are the individuals that don't? So we're going to be describing the overall pattern of our scatter plot by describing the direction, the form, and the strength of the relationship. And we're also going to acknowledge any outlier, which would be any individual that falls outside that overall pattern of the relationship. So one of the directions here would be positive. If we have a positively associated variable, then we're looking at above average of one variable tend to accompany above average values of the other. So high values belong with other high values. And then low values tend to correspond to low values of the other variable. Now, a negatively associated variable, or two variables, would mean that high values of one variable tend to go with low values of the other. So here we can see the scatter plot for the nutritionists and the Americans has a positive direction. We would describe the form as being roughly a straight line. There's some variation, but for the most part, you could imagine a line fitting through that data. But it's not particularly strong because there is a lot of variation from that line. We could look at the GDP graph. This one would also be positive because we tend to have positive values together and lower values together. But this would be more of a curved relationship. And we also would not consider this to be particularly strong because we do see a lot of variation among the trend line. And then here is a third example where we're looking at the weight of vehicles compared to the miles per gallon these vehicles are getting. So it makes sense that the larger a car is, the lower the miles per gallon would be. And we see that here in this scatter plot that does have this negative trend, has a negative slope. It is roughly linear, but it's not going to be particularly strong. We would call this a moderately strong graph because we definitely see a relationship between the two variables, but there's an awful lot of variation among that line.